Hello YouTube. So in this fourth lecture, we'll be applying what we've learned in the past two lectures. So separation of variables and integrating factors method to solve for IVPs or initial value problems. So in the two previous lectures, we covered how to generate general solutions for our differential equations using those methods. So in this video, we'll be able to use initial values to find more specific solutions given initial values. So initial values are basically when you're given a set of, initial values to solve. So for example, if we have the differential equation y prime plus 8y equals 0, and we're given the initial value y of 0 equals 3, then we'd be able to generate a more specific solution that satisfies both of these conditions. So you know what, while we're at it, let's just solve this differential equation. So we could use separation of variables by saying that y prime is equal to negative 8y. So now we now have two functions. We have g of y, which is our negative 8y, and we have our f of x, which is just this times 1. So we can start off by converting this y prime into a dy dx and dividing both sides by negative 8y. So we now have dy over dx times 1 over negative 8y equals 1. We can multiply both sides by dx, so we now have dy for negative 8y equals dx. We can integrate both sides. So we now have negative 1, 8 ln y plus equals x plus c. So now we can just multiply both sides by negative 8. So we now have ln of y equals negative 8x plus c. We can just raise everything to the e power. So we will get y equals e to the negative 8x plus c, or c e to the negative 8x. And we covered why we could just get rid of the absolute value in previous videos, because I said that c pretty much covers the absolute value. And then we can proceed from here by just plugging in these initial values. So let me just create an extra box. So we know y equals c e to the negative 8x, okay? And we know y of 0 is equal to 3. So by plugging in 0 into x, we have 3 equals c e to the negative 8 times 0 power. So we have c times 1. That would leave c equaling 3. Therefore, our more specific solution would be y equals 3 times e to the negative 8x power. Now let's try one more problem using a problem that would require the integrating factor method, and then I'll send you guys on your merry way to the next lecture. Oh, that was a bit violent. Okay, so let me just get rid of this. So let's say we have y prime plus 8xy equals 100x. And then we're given the initial condition that y of 5 equals 7. I don't know, I'm just coming up with random numbers in my head. Okay, so by using integrating factor, we know that p of x is equal to 8x, q of x is 100x. So then, because we know that u of x is equal to e to the integral of p of x dx power, we know that it's equal to e to the 4x squared power. So then we can plug it into our integrating factor formula, which is 1 over u of x, integral of u of x, q of x dx. So we get 1 over e to the 4x squared power, integral e to the 4x squared power, times, what's our q of x? 100x. So 100x dx. So now this becomes e to the negative 4x squared times integral of this. So after doing a nifty u substitution, we get 100 over 8 times e to the 4x squared power plus e. So this, let me do the quick math in my head. I think this becomes 25 over 2. So we get 25 over 2 plus c e to the negative 4x squared power. Now, given these initial conditions, we can figure out what the c is. So let me just erase some of this let me just erase this. You guys know how to get to where I am. If you have any confusion, you can just go back in the video. Okay, so we have 25 over 2 plus c equals negative 4x squared equals y of x. So y of 5 equals 7 equals 25 over 2 times plus c e to the negative 5 squared. Right? Okay, so 7 equals 25 over 2 plus c e to the negative 100 power. So we could subtract 25 over 2 from both sides. So 14 over 2 minus 25 over 2, that's negative 11 over 2 plus c e to the negative 100. So then c becomes, sorry, what am I doing? Equals. So then c becomes negative 11 over 2 times e to the 100th power. So then our final solution becomes 25 over 2 minus 11 over 2 e to the 100th power times e to the negative 4x squared. Or 25 over 2 minus 11 over 2 e to the 100th minus 4x squared power. And you can confirm that this is a solution by plugging this into this differential equation. I'm not going to do that myself because I'm lazy, but you could do that for yourself to verify that this is indeed a solution to the differential equation. Anyhow, thank you for watching this video, and I'll see you in the next lecture.